My name is Paul Jungwirth. I'm a freelance software developer out in Beaverton. I'm honored to be here to be part of the conference. I wanted to just thank all of you for coming and thank the organizers and the space providers. I'm going to be talking about error handling in Node.js. So Forrest's talk is really a great introduction to mine, and there will be a lot in here about using domains for your error handling. I'm not a Node expert by any means, but I had to deal with this recently, and so hopefully at the end, if there are other people who have things to add during the questions, feel free to jump in, and offer your suggestions. So I didn't have time to really add any jokes to this talk, so I thought that I would implement a server in Node.js to add a laugh track to the recording that the organizers are making, because it probably won't be very funny, and we can use some extra laughs during the course of the talk. So we've got this server here running on Node.js, and the idea is that you can give it an audio recording, and it will add a laugh track to it. It's asynchronous, of course. You can have your client, which is maybe an API server or something like that, make a call, and it'll fire off this encoding job, which might take a while. So we're not going to wait around before we give you back your response. We'll just tell you that your job is queued, and later we'll make a web callback to tell you when it's done. Whether it succeeded or whether it failed, we'll let you know. But if the server crashes, we want to still handle future requests. We would like any other current requests that it's processing to still be processed correctly. We want the web callback to still happen, and it'd be nice if we had a pretty good stack trace that we could use for debugging. So in other words, don't die and show us a good stack trace. These things require a little bit more work in Node.js than you may have seen in other languages. Here is an example of this server with no real error handling. What we're going to do is use this outside script that we're going to call through exec that's going to do all of the real work. We're going to encode it at 3 different quality levels. And here in the middle, you can see that if we have an error, we're just going to throw it. If error, throw error. This doesn't work too well, though, because it doesn't really meet any of our needs, right? It's going to bring down the server if something crashes. And we're not really going to see the reason for the failure. We're not going to see any kind of context. If something goes wrong, this is the kind of stack trace that we're going to get, right? There's nothing here. You don't see encode laugh tracks. You don't see anything about the request. There's almost nothing in this stack trace, right? It's just coming from this event emitter. So that's one of the things that we would like to improve upon. The reason for this is that for any asynchronous callback, you're getting a new stack. So you're not just going deeper into your stack as in a traditional language, but you're starting a new stack from the beginning. And so all of that context isn't present anymore if you want to look at the backtrace. So the implications are there's no stack to unwind, there's no context about what led up to the error, and there's no way to bubble up your errors to a higher level so that you can consolidate your error handling code in like a catch block or something like that. So we're going to look at some ways to improve on this. One thing you could do is to adopt more of a C-style error handling approach. So in C, there are no exceptions, and you're dealing with errors more by returning a special value, that kind of thing. And we could do something like that, maybe by replacing our if error, throw error. But that tends to be verbose. It can clutter up your code, and you still might be using libraries that throw exceptions. So you would still like some way of handling that case. So you might as well go ahead and use that yourself. One technique that people have adopted is using Forever.js, and this is a process monitor that will monitor your server and that will restart it if it dies, which solves at least one of our cases. It means that future requests will still get handled, that we don't just have an idle machine now, but current requests are still going to go down. Our webhooks are still never going to get called because these processes that we're executing throwing nothing there to see if they succeeded or failed. And it's not really helping us to get a good stack trace for our exceptions. So it's not really adequate for our needs. Another anti-pattern is you can listen for on-caught exception, right? But there are a lot of problems here. There are enough problems that it's now a deprecated approach. It can leak memory. It leaves you not really in a good state. And you still have the problem of not really having any context around the error, because this is a global exception handling mechanism that doesn't really tell you what happened. We could use a try-catch approach, right? But if you do this naively, it's not really going to work. Because we're starting a new stack whenever we have one of these asynchronous callbacks from an event emitter, this catch block is never going to see an error that's thrown, right? This error that we're throwing is going to go up its stack, but this catch block is somewhere totally different. So that's not really going to help us out. The solution here is to use domains, which were introduced in Node 0.8. They require library support, but my understanding is this has gotten pretty good so far, so you don't really see the warnings about it anymore. I believe the API still might change, but my understanding is that it's kind of stabilizing. And what they do basically is they allow you a way to scope your error handling. So whereas the uncaught exception hook is a global hook, these are, you can scope them to kind of however you want. Here's some source code that uses domains. You can see that what we're doing here is we're starting a new domain for each request, and then if any errors are thrown in that request, then we can make sure to handle them with the context of that request. So we could still have our webhook, for instance, calling back, knowing which request it was that had an error. But the problem here is that you could still wind up with undefined state if you are throwing an exception. You're probably going to wind up leaking memory in this case, so you still need to restart the server, and also you still don't really have a stack trace. But we're partway here, right? This gives us at least a tool that we can build upon. For a further step, we can add the cluster module. And cluster is another module in Node. It's also somewhat experimental, so maybe somewhat unstable. But the idea is that it will allow us to fork our node process and run with a master process and several child processes. And that way our child processes can die and the master can restart new ones. My understanding is that the motivation for the cluster module was largely to enable you to use up all of the cores on your machine so that none of them are sitting idle. In practice, I think that if you're doing asynchronous stuff, you're probably using all of those cores anyway. But it might be one way to make sure that you're maximizing your machine. In our case, we're really going to use clustering not for machine utilization, but just as a way to keep the request processes alive long enough so that we can finish up whatever we have to do before we kill that process and start a new one. And this will solve our memory leaks issue and our undefined state issue. Here's some code without domains, but just using cluster to show you kind of how it works. And this is pretty typical forking code, if you've seen that kind of thing in other languages. We're going to branch here on whether we are running as the master process or if we're running as one of the child processes. The child processes are going to do a traditional server and listening for requests. The master process is going to fork off the children, in this case, one for each CPU. And then it's also going to listen for if any of those children die, and it can respond appropriately by logging it or by forking another child or whatever you need. Now here is some exceptional Node.js code. See, that's why I need to add a laugh track to this talk. And sorry if it's hard to read. This combines the cluster code that we saw before with the domain code. So at the top, we have the master process, It's going to listen for the disconnect event rather than the exit event that we had here in the middle. We were listening for exit. We're going to prefer to listen to disconnect here because the child processes want to run long enough they want to disconnect, run long enough to finish off the request, and then exit. And we would like the master process to spawn a new child as soon as that disconnect happens. So we're going to listen for the disconnect event, not the exit event. In that case, it'll log something and run a new child. Most of this code is for the child processes. And as you can see, we're going to start a server. And now here's our domain code. We're going to fire up a domain for each request and register an error callback with it. Most of this code is for this error callback, as you can see. And this tells us that what we're going to do is make our webhook call to say that the request failed, and then set a timeout to kill this process after however much time you want, based on what's your standard request duration. So that'll ensure that it dies, and then we want to disconnect this worker so that the master knows to spin up a new one. Down at the bottom here, there's something that probably needs a little bit of explanation, which is where you have the comments for explicit binding. The way that domains work is that they hook into the event emitter, and that enables it to do this kind of scoping of error handling, to receive error events from only some event emitters in your code and not globally for all of them. So if you have a currently active domain and you create an event emitter or a stream, then it'll know to hook in automatically, and it'll just work like magic. But if you already have some of those that have been instantiated, and then you create your domain object, then you need to use explicit binding to manually bind them to that domain. So that's what we're doing here with our request and response object, just to make sure that they know about this domain. Just sort of a detail that you might have to take care of. So now we have safe error handling. This means that our current requests are all going to finish, our webhook is going to get called, and future requests will still get served. The one thing that we haven't really taken care of yet is getting a nice stack trace. And I think that this may have been one of the initial design goals of domains, but it doesn't really provide you this full stack trace yet. So instead, we're going to use a library called LongJohn, which works just like magic and will preserve this full stack trace for you. Basically, all you have to do is add a require line to your code, and you'll see stack traces like this instead. So now, we have this event emitter stack trace that we had before, but also we're seeing what led up to that. So we've got our encode laugh tracks method here, the request handling block, and we've got all of the information that we need to see where this exception really came from, what was the context for it. There are some configuration parameters that you can use for LongJohn, but I'm not really going to go into them now. They're pretty simple. If you're interested, you can look it up on GitHub. It's a library by Matt Ensler. And that's exception handling for Node.js using domains. Here's some references. Most of this talk is lifted straight off of the Node.js docs. So you can go to the domain page and the cluster page and see a lot of the same things, maybe with just minor modifications here. Some of these other web pages were really helpful to me in figuring out how to tackle this problem. I've got the LongJohn repository, and then this talk is all up on GitHub if you're interested in taking a look at it later. So thank you again. Are there any questions?
Where can we get your slides?
They're up on this GitHub repo. I'm going to put them online also, but yeah, the slides and the code for all the different approaches is all up there.